We learned how to simplify radical expressions in Algebra 1, but we want to do a little review of these topics. The terms. The radical expression is an expression that contains a square root symbol. So this is an example of a radical expression. The radicand is the expression under the radical sign. So we're talking about the 15a squared b to the 7th. That would be our radicand, whatever is underneath that square root symbol. First, we want to talk about how to simplify radicals. So the idea is that if this number, the radicand, is not a perfect square, then we want to be able to simplify it by taking out as many perfect squares as possible. So your Algebra 1 teacher might have taught you a few different methods. So if you don't remember exactly how to do this, just pay attention now. So we want to break this down into the factors that we have. So think about how we can divide 240. Since it ends in a 0, you know that it's divisible by 10. So 240 divided by 10 equals 24. Now these are our two factors. We can keep breaking them down. 10 is equal to 2 times 5. 24 is equal to 3 times 8. Now we can keep breaking down some of these. 2 is prime, 5 is prime, and 3 is prime. 8 is equal to 2 times 4. And if we keep going, we have 2 is prime, 5 is prime, 3 is prime, 2 is prime, and lastly, 4 is equal to 2 times 2. Now that we've broken down our radicand into primes, we want to take out the pairs. So we have this pair of 2's. One of them is going to make it out of the radical and the other one doesn't. We have another pair of 2's. One of them will make it out of the radical and the other one doesn't. And then the 5 and 3, they don't have a pair, so those are actually going to be stuck inside the radical. Now for our final step, we just need to multiply numbers that are outside and multiply numbers that are inside. And this is going to be our final answer. Next, let's talk about the product property of square roots. For any numbers a and b where they're both greater than or equal to 0, if you take the square root of two numbers that are multiplied, that is the same as taking the square root of one number times the square root of the other number. So just an example, the square root of 4 times 9 is the same as taking the square root of 4 times the square root of 9, which is going to be 2 times 3, which ends up equaling 6. The quotient property of square roots says for any numbers a and b where they're both greater than or equal to 0, if you take the square root of a divided by b, that's going to be equal to the square root of a divided by the square root of b. So again, if we use a number example and take the square root of 4/9, you can actually separate those and take the square root of 4 on the top, the square root of 9 on the bottom, so we end up with an answer of 2/3. Rationalizing the denominator. It's a method used to eliminate radicals from the denominator. So if we were to start off with this original fraction, the square root of a over the square root of b, what we're going to do is take this denominator and you're going to multiply the top and the bottom by that radical. Then what happens is on the top, we use that product rule, the square root of a times the square root of b equals the square root of a times b. Then on the bottom, the square root of b times the square root of b will actually just take that b out of the radical and we're left without a radical in the denominator. So a number example, if we have, this is the one you're starting off with, the square root of 5 over the square root of 3, multiply top and bottom by the square root of 3, so that square root of 5 times the square root of 3 equals square root of 15. And then on the bottom, the square root of 3 times the square root of 3 is 3. Now we've removed the radical from the denominator. So when we're simplifying radical expressions, a radical expression is in simplest form when the following three conditions have been met. First, no radicands have perfect square factors other than 1. Second, no radicands contain fractions. And third, no radicals appear in the denominator of a fraction. You're going to need to know all these rules of how to simplify radicals, and so that's why we're reviewing this Algebra 1 topic. That's it.